Hi guys, this is Sridhar Iyer. I'm the director of ML AI here at Versa Networks. AI over the past 2 years have gotten a lot of traction due to generative AI and ChatGPT and use cases as such. And it has become even more important for us to safeguard the data within the network and your whole organization using different techniques that we have at our disposal. We have different ML AI products that safeguards your data and provides a lot of access, prediction, and anomaly information that's happening on your applications as well as on your network side. So for example, we'll be able to block access to generative AI websites. We are also able to do a deeper dive and figure out what applications, what data is being shared with generative AI applications. So we can implement DLP rules, data loss prevention rules, to make sure that none of your private data is shared with those Gen AI websites. And we have a lot more generative AI, LLM based AI that we are using to safeguard your data. So let's look at a couple of the key components that are part of Versa AI with respect to security. One is file and data stream analysis. Then the second very important part is data loss prevention, where we keep track of what's happening on the raw network packets and we are able to predict any private data being leaked out of your network. Third is advanced threat prevention. And the fourth one is UEBA, which is user and entity behavioral analysis. So I'll touch over some of these components and then we'll go into a bit of detail into UEBA. So let's look at a file stream analysis when we look at malware, for example. So we have multiple different models and modules that take care of machine learning and AI when it comes to malware. So for structured malware, we try to create a repository of all the files based on streaming data, based on different resources, based on honeypots, and then we extract all the possible features that we can from these files. So these can be PE files, these can be PE file headers and stuff like that. So our security team works with the data science team to extract all these features out. We use this to generate multiple MLAI models and we rate these models on accuracy and performance. And after that, we create an ensemble model and we constantly update these ensemble models as well as the key component models. We update these metrics and we deploy them as and when it's required based on the different files. We also are able to create machine learning models for unstructured data, for example, JavaScript files and such, where again, once we have the repository of files, we are able to train an LLM to figure out what is a malware and what is not. We again rate the different models based on the LLMs, and we create ensemble models based on the inference capacity, where it's going to be deployed, the performance, and we again set up a continuous pipeline to deploy these models. These models can be consumed in two different ways. Either they can be deployed right on the edge on your device as a firewall on a firewall device, or it can be deployed on cloud as a microservice on a sandboxing service, for example. Or if you're thinking about advanced threat protection cloud, it can be deployed as a part of that as well. Now, when all the data that is flowing through us, so your API DP cloud, which is API data protection cloud, our CASB cloud, our SASE gateways, our remote browser isolation service, all these are piping their data and files to a common data warehouse repository, from where we look at all these data and we figure out whether these are malware or not, either based on the whole files or the way the files are sent, either based on network parameters or the file parameters. We rate them and we let the original service, the service that originated that service, the stream or the file content, know what's the status of that file. And then the individual individual service, Versa service, such as API DP, can take that input along with the input from other maybe email list or URL list to figure out how trustworthy the MLAI from Versa is versus the list it got from other third-party sources. So it can consume the data from all the different sources, and these individual components can make their own decision what needs to be done. Now, another key component that I would like to go into the details of is UEBA, which is User and Entity Behavioral Analytics. This is a very interesting machine learning AI problem, because here we are trying to look at a lot more logs that are coming from different sources. So these can come from Versa Analytics itself. It can come from third-party softwares like Microsoft Defender, or even we can absorb logs via from CrowdStrike, or it can even come from our own SASE client, which generates all these logs into our Vani UEBA cluster. Vani is our Versa Advanced Network Insights cluster that does network ops, AI ops, along with the SecOps for a complete network. Now, when the data comes in, it's all put into a graph database where we have a graph ML AI engine that's looking into this data. It tries to form connection of what's going on, tries to find anomalies, tries to do some predictions based on security, with respect to security, and then it generates insights which are sent to Versa messaging server, as well as it can be consumed by their own third-party CMs or dashboards that they might have. Now, this Versa messaging server will send this data and insight back to the VOS device. So you can have policies based on the current security posture of a user or a device or an entity or maybe the whole organization, and implement policies based on the real-time status of all these events that are generated by your MLAI models, maybe your API DP, CASB, or your other networking logs, or even your third-party logs. We can consume anything, right? So let's take an example of how this UEBA graph build-out happens. So for every event, here I'm going to just focus on Versa-generated logs. So let's say user logs in from location 1. So we'll have a session log saying that user logged in from location 1. So we'll create a graph saying user logged in from source IP 1, which was available, which is reaching out to location 1, from location 1, right? Now then the user accesses another app, Acme, which goes to URL 1 and which goes to destination IP 1. Similarly, user 2 also logs into location 2, and then user 1 logs in again from location 3, and user 2 accesses the app Acme again. Now what you see here is, unlike other log storage, we are automatically compressing the logs that are coming into the system. So I'm not storing additional logs that the user 2 has accessed Acme. It's just a node in an existing graph, which means that your terabyte scale log database can compress to a few gigabyte scale graph database where we can run our queries on, or where we can run our MLAI on very easily. So the cost to the customer is pretty minimal compared to existing log processing systems. Now let's look at how we augment these logs. So let's look at impossible travel. So if I have user logging in from 2 locations, I can very easily write a query which says, have these 2 accesses been in a short period of time, where if a user logs in from US and 5 minutes later he logs in from India, it's definitely not possible that the user logs in from 2 different locations in that short period of time. So we can generate alerts for those. We can find a URL is malicious or not by comparing it against our own URL blacklist, whether the user is accessing a risky country. So this can be based on a config that the user provides or the admin provides, that I don't want, if a user accesses any of these country, just notify me. I don't want it to be blocked just yet. I just want to notice the pattern, what the user is doing. So because you can easily implement block list on your device directly. In this case, you're saying, I want to know what he's doing along with other devices, right? So now we can use Graph AI to improve upon the data augmentation. We can figure out, is this location anomalous? So is this user logging in from a location where he has never logged in from before? Or if it's a new location, is it a location where the user or none of the user in the networks have ever logged in from? So we can find if this location is anomalous. Similarly, we can find if an application is anomalous. So is he accessing a gambling application on a corporate website? Or is the application usage itself anomalous, which means that this user is accessing a app like SharePoint, but he's downloading 10 gigs of data at the middle of the night. So his application usage might be anomalous. And we can do all sort of fancy blast radius analysis where we can say that user 1 is malicious. We know that because we consume the Microsoft Defender logs and it flagged the user as malicious. But user 2 is using the same application as user 1. What is the probability that user 1 is malicious as well, given that they are using the same location or maybe logging in from the same location or gateway or using the same appliance? So we can get into the brass tacks of a complete social media kind of graph within your network itself, and you can generate a lot of information based on what is generated by your network, right? And we have ever expanding list of all the features that we support in UEBA. So these include impossible travel, risky countries that I mentioned about. So we can figure out whether the user is downloading a lot of data or bulk upload detection. He's trying to log into a website multiple times, anomalous application usage, location usage, etc. We can consume other logs to figure out MITRE techniques. So we can figure out if the user is hitting on any of the TTP techniques that are well known in the industry. We can consume these Microsoft MITRE technique logs from CrowdStrike as well and construct a whole kill chain as to what the user is trying to do. And we can correlate it with the industry that the customer is in, and we can figure out what is the priority of this particular kill chain in the domain of that particular user. So if a user is in healthcare domain and we know that a particular APT is following these techniques, so we can say that this looks like a incident in progress, this looks like a kill chain in progress, and we can generate alerts accordingly. And again, all this is completely available within the Versa horizontal ecosystem. So once you, all the logs that we generate can be consumed by any other sources, as well as it is going to be consumed by your VMS itself. Let me give you a quick bird's eye view of how the screenshot looks. So here we can look at a particular user. We can look at which tenant he has logged into. We can look at when the incursions were done, what are the different activities he was doing. We can look at the different graphs. We can look at the graph of the social media graph of the application that the person used, where he is logging in from, what other users are logging in from the same location. What is the score? Score is the UEBA score that we provide based on what all activities has he done. And the rank is a page rank of which lets us know how important is he in the network. So if an intern goes to a risky country, a website in a risky country, that's lesser of a concern than if a CEO goes to a risky country. That might suggest that there's a lateral movement happening. So we try to figure out what is the actual rank of the user, and we prioritize all the events accordingly. All the events that we have, they have an event severity score, and they all work together to create a generic credit score kind of score, UEBA score for that particular user, which puts the user in a different confidence band, for example, trustworthy or suspicious or malicious or unknown, right? And based on those confidence band, the WAS can make a decision whether to block the user or to disrupt his cookies or completely log him out. So just bringing back the same vignette again, we consume the log, we augment all the data on the graph. We use MLAI to further augment and have a different kind of detection and anomalies done. And then we pass off our insights to Versa messaging server, which passes it on to WAS where these policies can be implemented. Thanks. That's all I had. I'll pass it over to Abhishubham now.
Thank you, Sridhar. In this section, we would look at different scenarios where Versa UEBA capabilities is helpful to implement, the scenarios that we cover as part of Versa UEBA, the configuration flows, how easy it is to configure these features on our portal, and we would look at the portal, the analytics engine, where we are able to correlate all these pieces together and see how a user is impacted or how potentially the user, that particular user, could impact other users and security operations. So this is the Versa Concerto portal, and we would look at a particular tenant here, which is this guy, US Bank. Now, when you look at the configurations, we would see all these different SASE features that are there for enterprises to configure. Let's look into advanced security and user entity behavior analytics. Now, as part of this UEBA, there are two pieces. There's profiles, where different use cases could be addressed, and then the user gets to create policies where we identify the interesting traffic on which we apply UEBA profiles. So let's look at the different use cases or profiles that enterprises could configure. Now, here in profiles under UABA, you see there are various options like bulk delete, bulk upload, impossible time travel. So there are different use cases when it comes to enterprise implementing UEBA functionality. A lot of enterprises want to prevent any kind of impossible time travel. A lot of enterprises that we discuss with the SASE possibilities of SASE implementations, they do not want any kind of bulk delete or upload or download, those kind of activities happening, which are particularly identifying user behavior. So Versa has a lot of these options. What you're seeing are pre-configured UEBA profiles. You could create your own profile. You could customize these predefined profiles to match your business and technical requirements. And once these profiles are created, we basically go to the policies and define the match conditions, and then all these configurations would be applied to our cloud infrastructure, and the traffic that comes in from the user based on the behavior of the user, these policies could be dynamically enforced. So let's look at one of these profiles here that we would be using in this live demonstration, which is impossible travel. Now, if you see here, what I'm defining is that the behavior type is impossible travel, and I'm just keeping these parameters standard. I'm just keeping the severity as medium. You could, depending on how critical that particular parameter is for your business, you could change the severity level. And for other behavior types like bulk upload, download, etc., there are other fields presented here that could be configured, like the count of the files, time interval in which we would look at that activity from that user, or the behavior analytics, behavior pattern of that user, and then enforce these restrictions for that specific user. Now, once these profiles are created, as we talked about, we go to the policies. Now, this is where we define the UEBA policy. Now, in this case, I'm just defining for a particular customer this impossible time travel policy, where we give options to users to make these UEBA profiles specific to certain applications. Let's say for a business, impossible time travel is only applicable for their internal applications or some business critical sensitive applications. Then the profile could be associated to that specific applications. In this case, I'm selecting all the applications, but again, the selection could be specific to certain applications. Moving on, we give options to users, to SASE administrators, to make it specific to a particular user, group, and application. So these are all match conditions. They are all AND conditions to make it very granular, so that you get very specific UEBA policies in your infrastructure. Once defining all of this, we go to security enforcement, and then based on your requirements, you could turn on various UEBA profiles that we just created. So in this case, for this particular demonstration, we would be using impossible travel. So I've got that checked in. Once that is done, you can review these configurations and save it. Now that we have UEBA profiles and policies configured, we looked at various use cases that come under UEBA, and the possibility is immense. As we grow, as we understand from customers, we keep adding these profiles to meet your business requirements. Now is the time to define where you want to apply this. Do you want to apply this towards your internet protection, or you want to apply this towards your private application protection? So to do that, we go to real-time protection, and this is where, for this demonstration, we would be applying it under internet protection section. Now, I want to highlight here as part of the ZTNA framework, one of the very important topic is adaptive access policies. So it's not just about ZTNA, it's about adapting to changing needs, changing behavior patterns, etc. Now, in this case, we would look at a policy that's going to adapt as per the end user's behavior. So in this case, we would be using the UEBA logic and associating that to an internet protection access policy. Now, this is where I've got this access policy created that I'm calling impossible time travel. And what I'm doing is here, I am putting it all the applications, all the users and group, no real time, the posture check right now configured, but you could do that. And then I just forgot to highlight this important thing here. In users and group, you have all the users selected, but what we are defining here is that the user confidence bands. So based on the end user's activity or the behavior of the user, you could define a dynamic adaptive access policies based on the confidence band. So Versa Cloud Engine, the UBA engine, would provide confidence scores to the users based on their activity. If they are going to sanctioned applications, their score confidence score is going to be good. But if they access unsanctioned applications or if they try to do any unsanctioned activity, then we would see degraded user confidence score. And over here, what I've done is I'm defining an adaptive access policy where I'm saying if the confidence band is any of these bands, other than the trustworthy, which is considered to be a good user, I want to enforce a very restrictive access. So as you can see here, I'm enforcing URL filtering posture failure. So this is a very restrictive URL filtering where for that user, where we are seeing a lot of unsanctioned activities going on, we would reduce or degrade the confidence score. And then once the user is part of that degraded confidence score, the access would be restricted to only a select set of domains. In this case, the user would still have access to Zoom and Teams, etc. But rest everything is going to be blocked. So in the demonstration, we would see that when the user logs in from a very remote location, which is not possible to travel in the given time frame, we would see that Versa would dynamically enforce or adapt to the behavior of the user and would restrict the user's access to certain applications. So, with this access policy or internet protection, adaptive internet protection policy in action, we would now look at this whole thing live. So, as you can see that I've got this client here that I'm connected to, and I am connected to the San Jose gateway. That's the user, gates at expertband.com. And if I try to go to internet and if I just try to access bbc.com, I am able to access that particular website. Now, I would go log into a remote machine. This is basically hosted in India, far location, and it's impossible for this user to travel there and to really connect unless the user is doing some kind of VPN or some kind of unsanctioned activity or behavior. Now, here when I try to connect to this particular cloud gateway, and you'll see me getting connected to the cloud gateway from this India location. Now we are connected to San Jose gateway. Now, as part of impossible time travel, this definitely qualifies. Now, if I try to go to bbc.com, you will see that I'm still able to go. Now, what is happening in the background is that the Versa UEBA engine, the cloud engine, is ingesting all these logs. Uh, and what it would do is it would basically recognize that this user cannot be logging in from a remote location based on its previous location, which was Seattle area. And the UEBA engine would flag that as an impossible time travel activity. And what we would see is that for that particular user, it would reduce the user confidence band. So let me take you to the live monitoring dashboard for this particular gateway and show you the confidence scores that we are seeing right now. So here we go to San Jose Gateway, and I'll try to go to the live monitoring dashboard of this gateway. And once we log in right here, I'm going to show you the user confidence bands, which is right here. And you can see that for this user, Gates at expertband.com, the user confidence score is now 19. Now, the higher the number, the bad the score is. So at this point in time, this particular user is definitely falling in low risk. And when we look at the policies, the configurations, we said that if the user is trustworthy, only then the user should have access to all the public and private applications. But should the score reduce or should the score degrades, we should restrict the access to certain applications. Now let's see if the restrictions are imposed. So let me try to go to some website like, oh, you can already see that it has started enforcing restrictions, and it says the message says that posture failure detected. Kindly get in touch with SASE administrator. Unauthorized access to resources is illegal. So this is a message. So if I try to go to CNBC, so you can see everything is blocked now. But if I try to go to some of these websites like zoom.us, that is still allowed. Versa's UEBA engine is able to identify an impossible time travel, which is related to user behavior. And the cloud UEBA engine, which is ingesting logs from our different gateways all across the globe, is able to identify that this user cannot connect from a foreign location in that duration. In just 5 minutes, the user cannot travel all the way to India and connect unless there is some kind of unsanctioned activity going on. And because this particular user and entity behavior analytics activity is unsanctioned, or for the business this is not acceptable, so the SASE administrators has enforced restrictions. And now, to look at the visibility that we provide as part of our UEB engine, you can see on this portal, which is our UEBA portal for this particular enterprise, you can see that there are various types of unsanctioned activities which are performed. And for these activities, you can see that you have the users and the number of times we have identified those activities, etc. Now, when we look at this particular user, Gates at expertband.com, in this case, you can see that um, well, I need to disconnect here because as you know that this particular user is now whether the user is connected from India or from US, the access is restricted. So I would have to disconnect so that I can show you what is going on with this particular user. So let me refresh. And now if you look at this particular user Gates, so you can see that the score is 19. And what we see is, as Sridhar was explaining us, the graph UI, where we provide all the correlation between the user, the applications, the location, etc. So we can see over here that for this particular user, these are the applications that that user is trying to access to. What other users who were trying to access same set of applications. Now this gives the SASE administrator an idea about the threat surface, like potentially what all other users could be impacted because of some unsanctioned activities that this user was performing. And this gives idea and troubleshooting steps for the SASE administrators to identify that potentially other users could be impacted, and which are those users. And the SASE administrator could define like how to troubleshoot these kind of any kind of problems that could arise because of this. So one last thing that I want to talk about, you also have this option here to reset the scores. So if it was like some kind of false positive when the SASE administrator talks to the user and they identify that, hey, that was for some business reasons, the user had to connect from the location in India, then we can, the SASE administrator could reset the scores. And once these scores are reset, you could see that now the scores are zero, which means that the user is not trustworthy. And if we try to go to any of these websites now, like cnbc.com, we can see that the user is able to access the websites. So this was a quick demonstration on our UEBA capabilities. We talked about some of the test use cases that we address as part of our UEBA features. We looked at the configuration construct, how easy it is to configure. You can have profiles and policies, and then you can enforce these policies on our cloud gateways. We also looked at adaptive internet protection access policies, where we look at user behavior and then adapt based on their activity, based on their behavior, and enforce restrictions to what they access, and what resources or what domains they can access when they are in that restricted phase. We also have capability to reset this, so that the user could we could get back to the normal business operations. I hope you like this video and you find this video informative, and thank you for watching.